Question 2. Find the coordinates of points of intersection of this curve and this straight line. Okay, whenever we have a curve and a straight line, or any lines lah, a straight line and straight line, or a curve and a curve, any intersection points you want to find, you have to solve the equations simultaneously. So usually this straight line will have its own equation, this one will have its own equation. You solve these two equations simultaneously, you'll get the intersection point. Okay, so in this case, you want to find the intersection between these two, you have to solve them simultaneously. Alright, so x over y minus 2y over x equals to 1. This is our first equation. 2x plus y equals to 3. This is our second equation. So from the second equation, we can try to make y the subject, because this is easy to make the subject lah. Y is just single here. So 2x we bring over that side, we'll get y equals to 3 minus 2x. We can call this equation 2a. Why I call it equation 2a? Because we have modified the equation 2 to get that equation. Okay. So why I like to call it 2a instead of 3? In some, most teachers or most textbooks you can see they make equation 3. But I see most students when they write this as equation 3, right? They accidentally, after figuring out this equation, they substitute inside the same equation. Then they'll get stuck. So when you rename it 2a, you must know that you can't substitute this equation back into 2. Cannot. You must substitute inside 1. So if equation 2a cannot substitute with the same number lah, 2. Right. So we substitute 2a into equation 1. Move this here. So x over 3 minus 2x minus 2 times 3 minus 2x over x equals to 1. Okay, so I just sub this y and this y with this value to get this. Okay, so now we have to simplify this. Let me just delete all this. Okay, we just have to expand and simplify this. Okay, so what do here is, I think the simplest way would be bringing this over the other side. So we get x over 3 minus 2x here would be 1 plus 2 times 3 minus 2x over x. So since this is 1, we can make the denominator same. This is 1 over 1. So top and bottom we times x, so that we'll get the same denominator. So x over 3 minus 2x equals to x plus, this one we can expand also lah, 6 minus 4x over x. Okay, so what I've done here is, instead of writing 1, I made it x over x. Then x plus this, we got this. Since the denominators are same, I just write it as x. And then here we can simplify. So x minus 4x will become negative 3x. Then I can erase this. Okay, so we've already simplified a bit lah. Alright. Okay. Now that we've got this, we can cross multiply. So x times x will get x squared equals to this whole thing times this, we'll get 3 minus 2x times 6 minus 3x. So we expand now. 3 times 6 is 18. 3 times negative 3x is negative 9x. Negative 12x plus 6x. Okay. I think I'm making a mistake here. 2x times 3x is 6x squared lah. Okay. Right. So then we can rearrange lah. So 6x squared here x square we bring over here. So 6x square minus x square is 5x square. Negative 9 minus 12 will give us negative 21x plus 18 equals 0. Okay. Once we are at this stage, we can factorize. So open up the calculator, you go to polynomial degree 2. A is 5, B negative 21, C is 18. So our x we get x is 6 over 5 and the other x is 3. So I left some space here so that I can put the brackets. So this will become 5x minus 6 and here will become x minus 3. So we get our two values of x lah. Once we find x ready, next we need to find y. So just now we saw y is 3 minus 2x. So we can say y is 3 minus 2x. Y is 3 minus 2x. So x here is 6 over 5 and x here is 3. So 3 minus 2 times 6 over 5 will give us 3 over 5. And then 3 minus 2 times 3 will give us negative 3. So we can say our coordinates of intersection will be 6 over 5, 3 over 5. And 3, negative 3. This will be our intersection points. That's it. This is the answer lah.